All right. So far, what we have introduced of the logical connectives last time is and, or, and not. And today we're going to focus on these two new ones: implication, or if-then, and equivalence, if and only if. And now we're going to focus on this one. So these are all five of the simple so-called connectives of propositional logic, and they all have fancy names and more simple names. So the simple names are and, or, not, if, then, and if and only if. And the fancy names are conjunction, disjunction, negation, implication, and logical equivalence. So let's look at implication now. And each time we introduce one, there's more complicated stuff to talk about afterwards, because there's all the different ways that it can interact with the previous ones and the rules for those interactions. Okay. So, implication. So it's called an implication symbol, and when you write a proposition on either side, it gives you a proposition. So this here is a proposition. And that's it for the grammar. You put a proposition on either side, and then the string of symbols as a whole is a proposition. Now, that's it for the syntax. Here's the semantics. Here's how we think of what this means. So you can read this in English as phi implies psi, or if phi, then psi, or psi if phi. These are all different ways of reading this out loud, or writing it in English. Now, if you want to prove, so I'm going to go through how to prove and how to use. If you want to prove an implication, let's say you want to convince someone that you want to convince someone using pure logic and whatever it is premises you agree on, that if they wash their hands, then they will not become infected. Then how would you prove that? If you wash your hands, then you will not become infected. You'd prove it by first assuming this side. Assume you do wash your hands. And then under that assumption, under that hypothetical, see if you can come up with an argument, some string of propositions that you both agree on, each deduction, that leads you to conclude that you don't get infected. So when you're proving one of these, you assume, just hypothetically, that this side holds, and then you try to prove this side. So in an implication, this part is called the hypothesis. This part is called the conclusion. And so to summarize, an implication says that if its hypothesis holds, then its conclusion follows. Let me show you in the table where this shows up, this idea. Okay, here I have the table, and we are down here on implication. And what I just discussed was how to prove an implication. To prove that if phi, then psi, you must assume phi, and then your task becomes prove psi. And you'll see some examples probably at the end of today's lecture. How about using it? Well, to use an implication, you can't unless you know the hypothesis is true. Then you can deduce the conclusion. Alternatively, if you know the conclusion is false, then you can deduce that the hypothesis couldn't have been true. That's via proof by contradiction. Okay, so let's discuss that. All right, here is the here are all the rules actually. Here's everything you need for implications. Here is a template for how to prove an implication. If you want to prove if phi, then psi, then you assume phi, then you have to convince the reader of psi, and that allows you to conclude the implication overall. And then for using, this is the main rule that lets you use, and then this is a rule that that you can deduce using proof by contradiction, but I'm just going to write it down here since it's so useful. You should just immediately think about it right away. So to use phi implies psi, you have to already have in hand, obviously phi implies psi, but you must already have in hand phi. And then what it allows is you can deduce psi. So if you know that, let me give you a more carefully constructed example. So let's say phi is you washed your hands and psi is you will not get infected. If you suppose you know, say you know for a fact that phi implies psi, meaning if you washed your hands, then you will not get infected. Say you know that for a fact. Then how can you use that to deduce anything? Well, if you didn't even wash your hands, then you cannot deduce anything from it, right? If you know that if you wash your hands, you will not get infected, and then you go ahead and you don't wash your hands, that doesn't mean you will get infected or not infected. You just cannot conclude anything, right? To clarify again, if the information you have is in the event that you wash your hands, in the case that you wash your hands, it follows that you will not get infected. Then in the case where you do not wash your hands, where phi is false, you cannot conclude anything. You cannot conclude psi, and you cannot conclude not psi either. However, if you do wash your hands, so if you both know that washing hands implies not getting an infection, and you wash your hands, then you can conclude, okay, I will not get infected. So that rule is called modus ponens. That was the rule I just showed you.